Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Welcome friends to lecture number 32 of the SwayamPrabha course titled Maritime Structures, offered by Department of Maritime Engineering at IIT Gandhinagar. One of its unique kind in the country. This program, Maritime Engineering, and the courses offered under this program are very useful and very captive for industrial placements, and also it fulfills the mission of our government of Blue Corridor and Save the Future. Friends, in the previous lectures on maritime structures, we understood about different geometric forms and how the form dominant design helps to alleviate the lateral loads acting on the offshore structures. Also we saw about some coastal protection structures which are constructed for strategic requirements along the coastline, etc. Then we discussed about details in materials used for construction, and we learnt about how steel compared to other materials are very useful and very commonly used in maritime industry because of its salient advantages in terms of its fabrication, weldability, etc. And we also saw how by allowing this elements can enhance the strength and its performance requirements as steel is concerned. Then we gradually understood what are the different kinds of loads acting on maritime structures: wave load, wind load, earthquake load, ice load, current, and so on. We also saw the different spectra. Fundamentally, we understood how the forces can be calculated at any space frame, at any instant of time, at any water depth on a given maritime structure, either using regular or spectra analysis. Later on, further down the line, we understood what are the construction processes involved in fabricating these kind of structures, erecting them, placing them and commissioning them. In this continuation, this lecture adds to understand the challenges involved in installation. Welcome to lecture 32, talking about challenges in installation. For example, we illustrate this more in detail using a jacket structure. Welcome friends to lecture 32. When we talk about installation in offshore locations, two important phenomena which comes into play, which governs the installation process, are as follows. One is of course the weather and wave condition. We call them as meta-ocean condition and the wave window or weather window. Friends, in offshore conditions, sea can be highly unpredicted. Though there are models available to predict the amplitude and period and direction of sea depending upon the weather window and wave climate, but still we call sea as a random phenomena. An unpredicted sea can cause large of dynamic effects on structures. For example, if these dynamic forces exceed the capacity of the vessel which is transporting the platform or the crane which is hooking up the platform beyond its limits, it can be a big challenge. So, though you have a vessel or a crane of certain capacity, the dynamic amplification caused on the structures by sea waves or wind make them exceed these limits, then it can cause a very serious problem. It can even result in capsizing of the whole platform which was fabricated for a specific use. So, the dynamic effects caused by environmental loads such as wave and wind predominantly amplify the loads acting on them. In specific terms, the dynamic effects are referred to as dynamic amplification factor. These are dealt in detail in dynamic analysis of offshore structures. However, we will also touch upon certain effects of this in the coming lectures in this course for our understanding. Of course, dynamic analysis is a full-fledged course offered under Swayam portal. You can look into that, but for interest of the learners, we will cover certain aspects of this in this course as well. So, what we understand here is unpredicted sea waves amplifies the load effects. We call them as dynamic amplification factors. When these load effects are amplified, there is a possibility they can exceed the barge capacity and the crane capacity as well, which can be one of the major challenge. Furthermore, it can also cause the dynamic positioning ineffectiveness. When the dynamic positioning becomes ineffective, then it can lead to slippage or unsafe conditions for installation. So, installation process is completely governed by various factors, predominantly the meta-ocean condition, the weather window or the wind and sea state conditions, and of course, the capacity of the barge, capacity of the crane, then amplification factors whether considered in design analysis or not. There can be all factors together can cause confusion or can cause ambiguity in the whole installation process. Furthermore, friends, if you look at the steps in detail of an installation of a jacket platform, which we discussed in previous lectures, there are different steps and stages involved in installing a jacket, transporting, lifting, launching and appending. During these stages, we need to ensure that not only the jacket fabricated remains in place, but also the vessel or the barge carrying this during transportation also remains stable. So, here we are looking at different aspects of engineering. We are talking about fabrication and welding, therefore, we talk about material science. We talk about analysis and design of structures under wave combinations and wind load combination. So, we talk about structural engineering. We also talk about operations, planning and also preparing the installation process. So, construction management, and of course, we also talk about the stability of the barge and the supporting vessels which are helping in carrying out this operation, therefore, naval architecture. So, friends, various disciplines are involved and various engineerings are looking into it. One, mechanical engineer, electrical engineer, naval architect, structural engineer, and of course, material science and construction executive. So, various disciplines are involved, various specializations are involved. Therefore, one can say, friends, installation is not only complex by its process, it is also complex by its knowledge domain. Having said this, let us look at this specific complexity by imagining that we are going to now launch a prefabricated jacket onto a site of specific location. The jacket behavior during launching and appending is essentially governed by a transient buoyancy force which is activated on this during the transportation process. When you have a jacket, which I will show step by step in the next slides, when you have a template structure or a jacket, the center of gravity of a jacket, which is the mass center of the elements involved in this, can get shifted because of its lifting and launching operations. When there is any shift in the center of gravity and where there is any added mass caused because of its partial submergence during the launching process, then the aerodynamic loads acting on those members will further add complexity to the whole process. So, friends, it is very important to consider the added mass effect and the aerodynamic forces acting on the submerged or partially submerged members during the launching appending processes, which are very important pivotal points in installing a jacket structure. In this whole process, the mass center or the center of gravity of the whole system gets shifted. When the center of gravity gets shifted, we all understand that the structure retains or attempts to retain a CG by shifting the bodily rotation towards its center. That is a general tendency of any body to attempt to come to equilibrium. We call this specific property in offshore engineering as recentering. We already learned them in detail in the previous lectures. I request the listeners to go back to previous module lectures and try to learn them further and reinforce your understanding before we take it forward from this point. So, very importantly, friends, when there is any shift in center of gravity and when the jacket gets partially submerged during the launching, load out and appending operations, there is an effect of added mass acting on these members which are partially submerged, and the aerodynamic loads caused by the waves and current acting on these members need to be added in the design check, otherwise it can impose complexity. So, therefore, friends, unlike land based structures, offshore structures or maritime structures installation is a very complex task. You must consider all combination of loads not only acting during the service life of the structure, but also expected to act during the launching, fabrication, installation, appending, uprating operations until it is transported from the fabrication yard to the construction site. So, all these forces which are unexpected to happen on the members of a maritime structure need to be also considered and checked in the design process, so that the platform or the structural system exhibits safety against these kinds of additional loads apart from the regular loads acting on the members. Therefore, friends, it is very important that a proper design check is exhibited, assuming the worst condition of transportation, launching, appending, etc. during the installation process as a part of the regular analysis, which is completely novel and applicable truly to only maritime structures. When we talk about the operation of installation, appending or uprighting becomes a very important task. We will talk about that. We spoke about that in earlier lectures. We will also talk about this in the coming slides in this lecture to make you clear and understand what are the different loads which are dominant under different stages of operation or installation process of a jacket structure. One of the important operation of a jacket structure is uprighting, or we call appending. Appending requires a controlled rotation, because from a near horizontal of a jacket to almost vertical, we are rotating the jacket. And we are not rotating a pencil object like this, we are rotating a huge structure whose mass is close to around 80,000 tons. Huge size, huge mass, and of course, they are all assembled and welded in such a manner to form a specific configuration. So, we cannot afford to lose a geometric distortion when this rotation or appending or uprating happens. So, therefore, friends, appending requires a controlled rotation which is happening, rotating the body from near horizontal to near vertical. During this operation, we cannot afford to lose the control, we cannot allow overloading on the slings, we cannot allow any additional friction or any load on the rocker pins or the ballasting system. Ballasting system is a part of the barge or the vessel which is carrying this, which is transporting the jacket from the fabrication yard to the place of installation. So, ballasting is actually adding additional weight to the barge to maintain its stability. Deballasting is removing this weight from the body to again maintain stability. So, ballasting, deballasting is a consequential operation happens in all ships, of course in barges as well, to maintain the stability during flotation. So, we cannot afford to lose the ballasting control, additional rocker loads on rocker pins or overloading on the slings of the crane hook, so that a failure can be initiated because of slippage happening from the crane drops. So, friends, lifting, launching and appending stability actually governs the whole operation of installation. For example, in a jacket platform. Having said this, let us see what is the further consequence or complication happens in a installation of a jacket. Once the jacket is transported, let us say the steps involved to recollect what we learned in the previous lecture. We said that I have a fabrication yard, where a jacket is fabricated. Okay. Now, the jacket has got a specific CG or COG where the mass center is located. This is a fabrication yard. In the fabrication yard tip, we have rocker pins, where, and we have a slide rails, where the jacket is virtually pushed along the rail towards the rocker pins. When it pushed towards the rocker pin, the barge is here. Let me draw the barge as well. Okay, let us say this is the barge. So, when the jacket is pushed and launched on the barge at the roller end, so essentially it is moving, and when it reaches this stage, the barge is partially loaded. Remember that the barge, when symmetrically loaded, is stable. When the barge is partially loaded, there is a probability that the barge may experience excessive roll or excessive pitch. So, this has got to be controlled by ballasting the barge to create a counterweight additional to balance this. Once the jacket is completely placed in position in the barge, maybe on the barge, then there can be a perfect balance of load. Still, remember, the CG of the barge and CG of the platform may not be same. It can cause an additional moment which can induce roll or pitch to the barge, for which the barge should be able to sustain this. Okay? That goes without saying. But however, there is expected to be a balance of the load acting on the barge, for which the barge stability is already ensured. So, now we have launched the jacket from the fabrication yard onto the barge. Now, the barge is moving. Okay? We are transporting now. When you are transporting, the wind effects while transporting, the wind effect, the wave effect and the current, in addition to the dead load, of the jacket should be taken care of in the design, right. The jacket should remain stable during the transportation process. Remember, the barge will also have the supporting cranes to help this process. So, the jacket placed on the barge will be also held in position so that it does not move. In addition to this, friends, both in the barge and on the jacket there are slip rings and C fasteners. Which are placed in position so that the jacket is locked on the barge. You must have seen this, a very interesting operation, which I can give a very simple example to recollect this. Let us say you have a ramp where, let us say this is the ramp arrangement, and the ramp has got a design like this, whereas this is hollow. Okay, this portion is hollow, this hollow. So, when you want to clean your vehicle for servicing, what we generally do, we bring the vehicle on the ramp, right, on the ramp. And we move the vehicle so that the wheels are placed here. The vehicle wheels are placed here, right. Once they are placed here, then you must have noticed that these wheels are locked. Okay. Then the cleaning and servicing of the vehicle takes place. Similarly, in aircrafts, when the aircraft is parked on the bay, you would see the wheels of the aircraft are also locked, so that the aircraft does not move when loading, unloading cargo or passenger embarkment takes place. Similar to this, friends, I have here slip rings and C fasteners to hold the jacket in place, so that the jacket does not move to and fro or oscillate or slide when the barge is moving. Okay. So, now we have placed the jacket on the barge. Now, the barge is moving, we call this transportation. When the barge reaches the site, when the barge reaches the site with the jacket in place, okay. Now, the jacket has got to be placed in position. Let us say this is the probable location where the jacket has to be installed. This is sea level, this is water level. Okay. So, now I have to have a crane which holds the jacket, and the jacket is slided with a rocker the same manner as you see here, and it is appended. Let us say uprighting. During this uprighting, you will notice that some of the members of this may get partially submerged, some of them may not, is it not? The partially submerged members will have added mass effect and additional hydrodynamic forces, for which this should be designed. Okay. So, now once it is appended and the jacket has become vertical, you have to do the pile driving. Okay. So, we are now coming to that option of what are the complexities involved in pile driving and interaction. The final support of the whole structural system relies on how strong and how firm the piles are driven in seabed and how they are firmly connected to the structural system of the jacket. So, the pile penetration and the skirt pile penetration on varied soil conditions govern the important aspect of successful installation of a jacket on site. When I say pile driving, we are talking more importantly about the soil structure interaction. Remember, friends, on ground or on site onshore, the soil may be not that wetted as it is in sea. Therefore, the marine clay or the marine soil conditions and composition are different from that of the soil on shore or on site in ground. They can be different. Even if you have a submerged water table, even then the soil conditions in marine or maritime system can be different from that of in soil condition under dry state system on earth or on maybe on onshore. Therefore, friends, the pile driving and the pile positioning and then fixing the structural system to the pile properly has got to be taken care of carefully. If it is not done, this can induce additional complexity of failure. we are now looking at what are the different processes involved in installing a maritime structure, example jacket platform, and we are looking at every stages how this can induce additional forces which can cause failure or complexities in the whole process. Now, once the pile is driven properly and fixity is ensured, then comes the question of final placement, what we call positioning and surveying the final placement. I mean, of course, jacket has got to be placed in a specific position, because the jacket is not simply to be placed wherever you want. It is to be placed at a geographic system where oil exploration can take place. So, we have identified the spot, we know the location, jacket must be placed in the specific location with zero tolerance practically. Okay. So, to ensure that, we need to check the dynamic positioning and survey of the final placement once it is commissioned. So, dynamic positioning, the vessel motion and the poor survey references can also induce a mismatch in the whole process of commissioning, what we call as misstabbing of the piles. The piles must have been stabbed at a specific geographic location, but there has been a wrong survey initiated, therefore, the misstabbing has happened. In many projects in offshore, friends, many piles might have been driven in the wrong location and they are lost. So, these are all added cost as well as added complexity in the whole construction process. Remember that, because accurately stabbing a pile at a specific location is definitely not an easy task in worst sea states and in marine conditions, because visibility is practically zero. You are doing this underwater, you depend on external agencies like remote operated cameras and acoustic signals to check the alignments and location, and you are not able to control the observed weather and observed forces happening during the pile driving caused because of weather windows. So, there are a lot of uncertainties involved in this process. Therefore, accurate stabbing of pile at a specific location is actually a most challenging task. This can also sometimes cause misalignment, which does not match with the pre-installed guides. We already have a template installed on the seabed. Pile should go and sit in that specific template location, but there are possibilities where misalignment happens and it does not sit on a specific location. Of course, there are tolerances for all kind of jobs, but practically we wish to achieve a zero tolerance procedure. During this whole exercise, friends, remember that there is a perfect load balance to be maintained. We are working offshore now, okay? It is not land based, so you can put lot of extra supports to hold the system until load transfer mechanism happens. But here jacket is appended and jacket is resting on the seabed on its own weight, but of course external excess buoyancy will try to push the jacket upward and so on. We need to check the load balance. We understand the jacket modules are very heavy and sometimes they have eccentric lifts also. You have seen a jacket geometry in the previous lectures. Because of appurtenances attached to the platform system, the weight or the COG may not be exactly at the center in terms of its vertical axis. There can be some eccentric lifts which can happen during the appending launching operations. Therefore, friends, poor spreader bar design or wrong sling configuration can induce unsymmetric loads on the jacket. We already saw in a lecture that what could happen if a member is under unsymmetric loading. We discussed very clearly about this the previous cases. We also learnt about it when the wrong sling configuration of a crane hook is used, what kind of additional stresses are induced in a curved beams. We already saw them in the derivations in previous lectures. So, during operation there can be a possibility of unsymmetric loading happening on the jacket. The most important worry here is, since the jacket members are long and slender, because we want to avoid the number of connection points, because of welding complexity, and we cannot afford to have lot of connection points because the intersection points will induce stress concentration. We will talk about that in the coming lectures. So, therefore, friends, the members are usually long and they may become slender, and that will induce additional buckling on these members. So, we already know the buckling load capacity of a member is far inferior compared to its axial load capacity. We already know that, because I can quickly compare this for your understanding. Axial load capacity or axial stress is simply the load by area which is resting this, whereas to compute the buckling load we talk about pi square A by L square, which is the Euler's buckling load, which depends not only on the configuration but also depends on the flexural rigidity of the member. So, the moment of inertia about the bending plane, the length between the connection points, what we call otherwise effective length, plays a very major role in controlling this. So, in general, friends, with the given inference of information we have, we can say that generally the buckling load capacity of a member is lesser than its axial load capacity. A member may be safe in axial load, but may become unsafe under buckling conditions. Now, buckling will be induced during this construction process because of two reasons. One, eccentric lifts, and because of sudden slip caused by wrong sling configurations. Once the member buckles, the load carrying capacity of the member gets degraded, and therefore, the jacket cannot sustain the design load. So, then the question comes, how will you manage the topside compensation of these loads after you install this jacket? We will talk about that later, but load balance becomes a very important aspect in the installation process as we discussed. Friends, should you have any doubts or questions at this point, you should post them in parallel to the discussion forum at SwayamPrabha. Instructors will be able to look into that and share our views and comments and more literature references to make you understand clearly about these points. So, please be free to write your comments and do learn this course with full seriousness, so that this is a very important and very innovative content of lectures given to you by IIT Gandhinagar, which will help you to understand and become professionally sound to work in a maritime industry, which is a better scope industry in engineering sector in the coming years in India. So, friends, having understood the complexities involved in this, what are the further chances where additional loads can come in during installation process? The transient hydrodynamic loads which will cause or which are arising from the additional wave swelling effects, additional transient loads, they will not remain for a longer period, but they have an impulse effect on the member and they happen to attack the members during installation process. Additional loads, they are not designed for which the members have to sustain. So, these kind of transient hydrodynamic loads and complex soil structure interaction during driving of piles can also amplify the dynamic effect during launching. Of course, we agree that jackets have heavy weight structures, therefore, we require special lift vessels to hold these jacket structures. We cannot use a conventional barge to do this. Launch vessels are configured in such a manner they are able to maintain the balance when transportation or launching happens. So, we need special configuration vessels for transporting jackets. A small tilt during lifting or appending by ballast control can cause failure to the whole system. So, it is very important to choose a proper lift and launch and transporting vessel or a barge to do the jacket launching. During transportation, when the jacket is being transported from the fabrication yard to the installation site by the barge or on the barge. Damage can also occur during this transport period. It should be prevented and the stability of barges should be ensured. As I said, generally when the jackets start tilting about its CG, which is not essentially in its center, this can cause additional roll and pitch on the barges, and that can improve or that can improvise instability in a hydrodynamic perspective to the barges. So, the barges should be tested and ascertain that they remain stable during the transportation operation. Connecting the transition piece, which is essentially the joint between the connections, and securing the legs with the piles with the grout is a very complex task, friends, because all these have to happen under water. Okay? Poor visibility, poor accuracy check, very prolonged and fatigue based construction process, delayed and uncomfortable weather window can all improve or add to the complexity of this process. So, these should be taken care of and should be done with a great care. Now, let us see what are the challenges in different stages of installation. Talk about load out. Load out is the process where the jacket is loaded on the barge from the fabrication yard. That is what we call load out. Okay? The jacket is now loaded out from the fabrication yard to the barge. During load out, generally jacket is laid horizontally, okay, and gently tilted by the rocker pins. The change in slope while tilting can create additional stresses on the members. You have a straight body. When the straight body is tilted, the mass center gets shifted and the stress concentration on the joints of this member gets varied. Okay? So, one has to be very careful that additional stresses caused during this operation should be checked. When the barge is anchored in position to hold the jacket onto it, sudden drop of a huge jacket can also cause imbalance on the barge. You have a barge, okay, you have a barge, okay, and you have a jacket which is huge in size. Okay. When you start loading this onto the barge suddenly, when you do this suddenly, the barge may lose its stability. This you must have seen when you are boarding a vessel, it is a passenger vessel, from the coast to the vessel, you will notice that as people keep on loading the vessel will start rolling. Then somebody has to help you to hold your hand to bring you from the port to the vessel. Similarly, when you leave the vessel, same manner, if the vessel is very large and very stable, you will not notice this roll motion. But the vessel is not that stable and that large, you will notice that the roll is quite significant. So, when you happen to have a load out operation, suddenly or any slip happens, this will increase destabilizing condition onto the barge. So, the barges, if loaded suddenly, can cause destabilization. Sometimes, friends, it can even cause sinking of the jacket because the barge will move, though it is anchored. Okay? The barge will move and the jacket will sink. Of course, there are crane hooks, slings which will hold the jacket from the fabrication yard, which can be recovered, but the operation is unsuccessful. Okay? So, therefore, in the design, barge plus weight of the jacket should be accounted, and this total should be lesser than the buoyancy force acting on the barge. this check has to be done. Okay, this check is very important. So, the barge plus weight of the jacket should be lesser than the buoyancy force acting on the barge. This has got to be checked to maintain and to ensure that the barge will not get into destabilizing mode when the jacket is loaded out onto the barge. Let us now see what are the different processes of installation and what are the critical loads acting during this process. The first one, as I said, is a load out. I have made a line figure of this from the fabrication yard. The jacket is loaded out on the barge. So, the structural members are critical here are of course the barge, no doubt about it, then the rocker pins, which are also very important, then the skid beam. This is a skid beam, I will mark it here. This is a skid beam, these are C fasteners and the rocker pins are here. Okay. So, the C fasteners, which are actually the lockers which lock the jacket on the barge, so that the barge does not move horizontally laterally. Skid beams are used to move the jacket to and fro during the launching and load out operations, and rocker pins are enabling the jacket to rotate, which helps to load out the jacket from the fabrication onto the barge. So, these are very critical elements which needs to be taken care of in the check. Let us see what are the loads acting during the load out operation. Of course, the self weight of the jacket is very important. The rollers where the jacket skid and roll over, the friction force on the roller plays a very important role. Okay? The roller should sustain this force so that the roller does not get damaged and enables rolling comfortably when the load happens. Of course, when partially the barge is loaded, the reaction force from the barge should be counted for it. The barge should not move, neither it should get destabilized during the loaded operation. So, the jacket self weight, roller friction force and reaction force from the barge comprises critical force combinations in the loaded operation. Okay, this is operation number 1. Once loading out happens, the jacket is on the barge. Okay, it is on the barge now. Now, I am going to tow the barge using a tugboat. During towing, as we all know, the jacket should not move, is it not? So, the C fasteners will lock the jacket with the barge, they will not move. Then what are the forces acting here? The dead load of the barge plus the jacket, the hydrostatic pressure which is caused because of this towing, the dynamic amplification because of the wind and wave acting on the barge, wind acting on the jacket. They will all get dynamically amplified during the towing operation. Further, there can be additional forces when the barge is at rest position, because the tugboats cannot continuously pull this from the destination or from the fabrication yard to the destination. Under rest position, the whole system will become an integral unit subject to wave and wind action. Okay? If the jacket is not placed in relation to the CG of the vessel, if the jacket is tilting because of failure of fasteners, this will induce additional moment on the barge and the barge may get destabilized. So, these are the forces acting during the operation towing in the second operation. The third one is the launching, that is, from the barge I have got to push out the jacket onto the site. This is called launching. During launching, what are the forces acting or what are the forces governing this operation? One is of course the dead load. Friends, please note, when the jacket is getting launched, when the CG is shifted away very much from the CG of the vessel will now experience rotation, is it not? this will now encounter excessive roll. The vessel should not get destabilized during this operation. How do you do that? You have the ballasting effect here, which will counteract the weight, add ballasting weights here to control this additional roll. Okay? There are of course additional methods by which the roll control can be done. We have explained this process for a drill ship using AI driven passive dampers. Okay, this can be a very interesting PhD research problem where the whole launching load out operations can be maximized for its operational safety in the maritime sector. This can be a research problem where I invite people to undergo or undertake this research under our guidance at IIT Gandhinagar. So, let us see what are the additional forces critically govern the launching operation. As we said, excessive roll, which will caused by the dynamic effects of wave and wind, forces caused due to sliding friction, because it is sliding now, can have a friction force, that can be an additional force. Forces at the joint due to change in position. That is very interesting, friends. Even in the jacket, when the position is changed from here to here, the joints will now experience different forces. So, these joints should be checked for that kind of operation in the analysis. So, during launching is a third operation. So, let me write down these operations very carefully. Let us say load out operation, operation number 1 or stage 1, towing is stage 2. Once towing is done and is reached the site, then launching is stage 3. Then comes the floating. Let us say the jacket is now launched in sea. Of course, it is held with the crane, okay? It is held with the crane. Now it is floating. And then gradually it is uprighted. So, we can also call this as uprighting or appending. So, let us say this becomes the 4th stage, this becomes the 5th stage. During this stage of construction, the critical forces governing them are the buoyancy force, because the buoyancy will now govern the design as it is floating, the dead load of the jacket, the lateral loads caused by the wave and wind. Of course, the wave effect is lesser, but the wind effect is lesser, wave effect is phenomenal. Effect of current plays a role here. Current is most predominantly present on the surface of waves. Current is very effective here. Hydrodynamic forces caused by waves and the load due to mooring of the vessel. Okay, that is very important governing factor here. The barge should stay in position during appending. If the barge moves, the barge is unstable, then appending cannot happen properly. So, during floating and appending, these are the governing forces which need to be considered in the analysis. Once the jacket is in the vertical position, let us say is operation 6, in vertical position, then piles need to be driven. So, I now worried about the soil structure interaction, the dead load and the wave force and current effects acting on the jacket now. So, friends, in the sequence of operation, what we like to recollect again, like fabrication, of course, one part happening on the land. So, fabrication, then load out, then towing, then launching, then floating, appending and vertical position. So, these are the different stages of installation in maritime structures. This is generally applicable to all large maritime structures like gravity based platforms, jacket structures, guide towers, large floating structures, etc. Let us talk few minutes about the planning and execution during the installation process. The installation plan should be prepared including the methods and procedures for the load out operation, safe fastenings and transportation. Installation process different phases, we saw that: load out, sea fastenings, transportation, installation. Let us try to understand more about the C fastenings. C fastenings are actually ties and fastening locks together called C fastenings, which are used to hold the jacket on the barge during the transportation or during the launching operations. They should be designed in a proper manner, provided both in the barge as well as in the jacket, and the major function of them is to prevent sliding and shifting while they are in transit. Example, when the aircraft is landed, the wheels are locked. When you are leaving your car for servicing, the wheels are locked. This lock is what we say here as C fastenings. During towing, including the platform, C fastenings and bars should be analyzed for gravitational, inertial and hydrodynamic loads. Analysis should be conducted based on the basin test for beam C, head C and quarter C conditions. Beam C and head C are, for example, if this is my barge, so beam C, head C and quarter C conditions. For all conditions of wave direction, you must check the analysis for its safety. Now friends, a very peculiar problem. I have a barge, let us say of a specific capacity. But the jacket is longer than this. Okay, it can happen. It can happen. You must have even seen on trucks where people carry large pipes longer than chase of the truck. It happens. You must have noticed that they would try to place the pipes in the CG of the truck so that the members do not bend. If this would have been placed like this, you will notice that these members will experience excessive bending and buckling. Okay. So, when the jacket is longer than the barge, then the problems are slightly different. For large size jackets, when they extend beyond the size of the barge, submergence will occur during towing. This submergence will have added mass effect and additional forces caused by wave slamming, buoyancy and collapse forces. They should be checked in the analysis and design prior to the design is completed. Furthermore friends, when the jacket is being towed, when the jacket is longer than the barge, it will also cause something called wind induced vortex shedding vibrations. This will cause second order effects on the member stresses. To avoid this, one can bundle the whole jacket by wrapping the wire rope helically around the members. This can save the whole jacket under the effect of wind induced vortex shedding vibrations. So, there are problems, there are solutions also available in the literature. So, by experience, the maritime engineer decides what kind of barge he hires, how he places the jacket on the barge, how safely he transports and transits the barge from the fabrication yard to the construction site. Having said this, during launching and uprighting, the guide towers, template structures etc. are launched near the installation site. We know jacket is moved horizontally, longitudinally, then rotated at rocket arms and launched on the deck of the barge. We already saw that procedure. When jacket position reaches the point of unstable equilibrium, the jacket rotates. We know that, is it not? As I keep on, look at here, when I keep on, this is a barge, let us say the barge tip, the rocker arm. So, keep on sliding the jacket, you will see when the CG crosses this arm, jacket will automatically rotate, is it not, because of its weight. Okay. When the jacket moves ahead of the barge, because of its weight shift, it automatically rotates on the rocker arm, right. So, the rocker arm terminators will help to rotate the jacket automatically on the barge. The jacket rotates and slides from the rocker arm gently onto the barge. But in this case, the deflection of rocker beam and force on rocker arm governs the design now, because if the rocker arm crushes or the rocker beam is not able to take the load of rotation, then it fails. Okay, it gets stuck there. So, one has got to also look in the design of these and they should be checked properly. Large floating structures generally lifted by vertical position by cranes. Therefore, hook loads which will govern the design construction process should also be checked for upright operation. Submerged members, in case when the members are larger than the bar size, will be governed to resist the pressure caused by the hoop stresses during launching and uprighting. So, that should be taken care of in the design. Launch barge should be equipped with launch bays, rocker arm, control ballast facility and dewatering system to maintain the stability of the barge during launching. Hydraulic ramp winch system is required to assist jacket sliding. So, friends, let us come to the summary of this lecture. In summary, in this lecture, we learned the installation process. We understood different steps involved in installation. Of course, we learnt it with an example of a jacket structure, but they are more or less common to all large floating structures like guide towers, gravity based structures, etc. We also understood what are the different critical loads that act during installation and what loads and design elements should be checked. We understood that the loading operation is quite cumbersome. It is quite uncertain. Therefore, various design checks are necessary to ensure safe installation. So, friends, I would love you to show a video where a real time installation happened, but because of strategic reasons this cannot be shown to you. However, there are short videos available in the open domain. I will urge you to look at them conceptually to understand and then correlate the contents of the lecture to understand the engineering perspective behind this lecture. Hope you understood the lecture, you enjoyed the lecture. Thank you very much. Namaste.